All right, let's finish up DSMA 12. So we have another multiplication problem. We have two rational expressions. So we do have to worry about our exclusions. We're going to come down here and do that in just a minute with this not equal to. But let's go ahead and factor. So with the first one, we need factors of 6 that sum to -7. So that's going to be x minus 1 and x minus 6. Because if I multiply them together, I'll get positive 6. -1 times -6 gives me positive 6. -1 plus -6 would give me -7 in the middle. All right, then we have factors of -24 that give us -2. Let me see here. I think we're going to have 6 and 4. So we are going to have x plus 4 and x minus 6. All right, so if we check our work, we have 4 times -6 gives me -24. 4 plus -6 gives me the -2 in the middle. Now you do whatever method you need there. You can, I'm just kind of doing the guess and check, but that's how I learned as a kid. But you are welcome to just take your time and lay out all the factors of -24 and see which ones would sum to the -2 in the middle. All right, on the second one, we are going to take, let's see, that's the difference of squares. So we have x plus 4 and x minus 4. And then finally on the bottom, that is also a difference of squares because we have x squared minus 1. So that would be x plus 1 and x minus 1. All right, so before we get going with trying to simplify this, let's go ahead and grab our exclusions. So we've got x plus 4 here, so that would give me a -4. I have x minus 6 here, so when I set that equal to 0, it's going to give me plus 6. Here I have a -1, and here I have 1. So we're taking each of those binomials, we're setting them equal to 0, okay? And that is giving me all the exclusions. Those are all the numbers that would cause either of these expressions, one or the other, to have a 0 in the denominator. And as soon as I have a 0 in the denominator, then I have a problem because then it's undefined. All right, so I'm going to go ahead and put these in numerical order. It truly doesn't matter. The computer's going to take it either way. But those are our 4 exclusions. Now we're going to go ahead. Remember, we have to do that first. I'm going to rewrite this, and we'll see what we can get rid of. So I'm going to put them all together because, again, when we multiply fractions, we multiply the numerators, we multiply the denominators, and then we'll just run along and see what we can get rid of. So it looks like we have an x minus 6 on both top and bottom. We have an x plus 4 on top and bottom. And finally, we have an x minus 1 on top and bottom. Looks like that's it. So we are left with x minus 4 on top and x plus 1 on the bottom. So you can see if I waited to simplify, or excuse me, to find my exclusions till after I simplified, I would have only found one problem child, and that's not going to work. So we have to check for our exclusions first, and then we can go ahead and simplify. So this first box is going to contain the simplified expression. The second box is going to contain my exclusions. All right, so now we're going to divide. So when we divide fractions, we, let me think of a problem here. We'll do 3/5 divided by 1/2. All right, so what we do when we divide fractions is we keep the first fraction, 3/5. We change the division to multiplication, and then we flip the second fraction. So that's finding the reciprocal. It's called the reciprocal. The numerator becomes the denominator becomes the numerator. All right, and now it's just a multiplication problem. So now you just multiply across. 3 times 2 gives me 6. 5 times 1 gives me a 5 on the bottom. Okay, so we're going to do the same thing here. But there's always a but, right? We have to check for exclusions before we flip and after we flip. Okay, so I'm going to go ahead and factor this. When I factor, I get x plus 2 all over 6 divided by 3 times x plus 2, right? There's a greatest common factor in there, all divided by 5. Now for this one, I can check for my exclusions, but there's no variables in the denominator. And so I don't have to worry yet about exclusions, right? Because it's a 6, it's a 5. There's no way to make those equal to 0 because there's no variable. And so I do not have to worry yet about those. So now let's go ahead and do. So we're going to do keep. That means we're going to keep the x plus 2. I'm going to go ahead and put those in parentheses. Divided by 6. That's keep. Then we're going to change. So what we're going to do is the division is going to become multiplication and then flip. So now we're going to, the denominator becomes the numerator and the numerator becomes the denominator. Okay, so we checked here, but there weren't any. But now we have to check again. Now that we've flipped, we need to check again for exclusions. And sure enough, now I have a variable. And so x plus 2 equals 0 or x equal to negative 2. So negative 2 is going to be a problem child for me. It would cause that second fraction, when I flip it, to have a 0 in the denominator, and that's undefined. So negative 2 is not going to work for us for this expression. Okay, so now that we've done that, now we can go ahead and let me rewrite it over here so we can take a look at it. So we've got x plus 2 over 6 times 5 over 3 times x plus 2. The x plus 2's are in common, but that's it. So on top, we have 1 times 5. On the bottom, we have 6 times 3 times 1, and so that gives me 18. So that is as simplified as I can get. I got so simplified that I don't even have any variables anymore, but I do still have my exclusion of negative 2. All right, this is starting to get more interesting. Let's go ahead and factor first before we divide. So on the top there, I'm going to look for a greatest common factor first. Looks like I could pull a 3 out of there. I can't pull any x's because the 12 doesn't have an x. Now, inside there, I'm not going to be able to factor any further. I know we have 2 terms, and if that had been subtraction, we could factor a little bit further. But since it's addition, remember we cannot factor a sum of squares. And I know 3 is not a perfect square, but we have some other tools. But we're going to leave that alone because we would actually, if we put that in the quadratic formula, that would give us an imaginary number, a complex number. So we're not going to mess with it. We're going to leave it be. Okay, so we still have that x minus 2 on the bottom. Then we have division. On the next numerator, looks like I can pull a 5 out of there. And that leaves me with 3x squared plus 4, that same thing. Now, on the bottom, though, I have, let me put parentheses here. I have a difference of squares. I have x squared minus 4. So that gives me x plus 2 and x minus 2. Okay, so let's go ahead and check for our exclusions. We always want to do that before we do our keep, change, flip. Okay, so we're going to check. for exclusions. And we have a positive 2 here, we have a negative 2 here, and we have a positive 2 here. So let's put negative 2 and positive 2. Okay, remember we're setting each of those equal to 0. So you set x minus 2 equal to 0, that gives you 2. X plus 2 equal to 0, that gives you negative 2, and so on. Okay, now let's do the work here. So we have keep. We have change. So we're going to change this to multiplication. Ah, come on, stylus. And then we're going to flip. And then normally we would at this point have to check again, but this is actually going to give me an imaginary answer, and so I'm not going to worry about that with this problem. I'm going to go ahead and only take real numbers for our exclusions. So this is kind of a different kind of problem. Okay, so let's go ahead and simplify. Looks like I can get rid of the 3x squared plus 4. I can get rid of the x minus 2 because I'm dividing them out to get to equal 1. I think that's it. So on top we have a 3 left, and we have x plus 2. Looks like on the bottom we just have 5. All right, so that is as simplified as I can get. It's pretty simplified from that first one. We actually use these a lot in science. You'll find when you head on to chemistry, physics, and you start messing with the algebra in the science. And then our exclusions are negative 2 and positive 2. All right, so for you guys who are wondering, I want to go ahead and set this 3x squared plus 4 equal to 0. So what would happen is we would get 3x squared equal to negative 4, and then we would get x squared equal to negative 4 thirds. Now when we go to take the square root of both sides, we would have x equal, and we would have plus or minus the square root of negative 4 thirds. And we would have to clean that up because we don't allow a square root on the bottom. So you'll see if you go in and put in your calculator the square root of negative 4 thirds, it's going to give you 4 times the square, 2, not 4. All right, let me put it over here. Plus or minus 2 times the square root of 3 over 3, and it's going to be all times I. Because remember, when we take a square root of a negative number, we're going to have an imaginary unit, right? We have an imaginary number. And so, and then we would have to do what we call rationalizing the denominator. So you don't have to do all that. That's just for my thinkers in the room. And it's all because it's a sum of squares. And the problem is with the sum of squares, you're going to end up taking the square root of a negative number. And that's where we move into having to use imaginary numbers. All right, one more division problem. All right, so let's factor. On the top, we have a difference of squares. 9 is a perfect square. On the bottom, we have 7 times x minus 1. The only factoring we can do is pulling out the greatest common factor. On the top here, we have x squared plus 6x plus 9. So that's x plus 3 times x plus 3. And then finally, on the bottom, we want factors of 3 that sum to 2. So that's going to be x plus 3 and x minus 1. All right. So let me just double check my work here. Okay, so before I do my keep change flip, I have to go ahead and look for my exclusions. So from here I have -3. From here and here, both of them, I get a +1. Right? So those are, so far, the two numbers that would cause my denominator to equal 0 and give me an undefined expression. Okay, so let's do our keep change flip. So keep, change, flip. Okay, now we do need to check again, just in case. So we're going to check our denominators again, because we need to check. We have x minus 1, that's +1. We already have that one. We have x plus 3, which is -3. We already have that one, and we have that one. So we're good to go, but we do have to always check. So you check before you flip, and then you check after you flip. All right, so let's see what we can get rid of here. We can get rid of the x plus 3 here. Looks like we have an x plus 3 here and here. And then finally, we have an x minus 1 here and here. So we're dividing all those out. And looks like after we do all of that, we end up with x minus 3 on top and a 7 on the bottom. And so that is our simplified expression after we finish dividing. And then here we have our exclusions. All right, that is it for DSMA 12.